Hi everyone, my name is Brendan Foley, a customer engineer here at Google. I'm joined today by James Spiteri, a product marketing director at Elastic. We're both very happy to be here today and to talk to you about how teams and organizations can utilize the Elasticsearch platform on Google Cloud to investigate and prevent application exploits. We'll also talk about the advantages of combining application observability and security events into the same platform, and we'll see this live in a demo. We all know that data is at the heart of the modern enterprise, and needless to say, at the heart of modern security analytics. Unfortunately, security teams have long relied on what we consider traditional security events. Think endpoint logs, firewall logs, etc. While these are, of course, important, the events which occurred in December showed how those are simply not enough. Following the events which occurred in December, it became even more evident why these different solutions shouldn't be siloed. James, why don't you go ahead and explain what you'll be seeing as part of the demo?
Yeah, awesome. Thanks, Brandon. Before we shift into the demo, I'll just quickly talk through the slide that I have here to show the setup we'll be using for this particular use case, which was the log4shell exploit, which are the events Brandon was referring to in December. So we've got a vulnerable Java application running here on our hosts, and we've just exploited it with log4shell. This application is instrumented using our Java APM agent, so application performance monitoring, which is going to give us really deep insight into exactly what the application is doing. That data is being streamed into an Elastic Stack hosted on Google Cloud. Here's a demo now to talk about the other infrastructure elements and everything else we have running on our machines and how we can use the different solutions within Kibana to investigate this exploit. Okay, so let's dive right into the demo. So first things first, I just wanted to show you all the components that I've set up for the purpose of today. So we've got an Elastic cluster running out of Google Cloud, specifically the Belgium region. This is the Elastic Cloud Console, but you can also invoke the creation of these clusters through Google Cloud Platform itself. And we have various different regions that you can use. From the Google side, we've got a couple of compute instances that we'll be monitoring. We have Google Cloud Bucket, which is going to be used for an Elastic feature called Searchable Snapshots. It is just an ordinary Google Cloud Bucket, but it's going to be used for a very powerful purpose. We've got a pub subtopic, primarily collecting our Google Cloud firewall logs, and of course the Google Cloud firewall rules themselves. This one specifically is going to be doing the bulk of the work for us. Now that we have everything set up, let's see what it looks like on the Elastic side. So we've got our Elastic Agent Google Cloud Platform integration, which is collecting primarily the PubSub events. We've got our Elastic Agent also running our endpoint security integration on those compute instances. Now, I've said that we've exploited a vulnerable application with the log4shell exploit. Let's see what we're able to find now within Elastic with all these Google datasets. So looking at our alerts view inside of Elastic Security, we had a couple of different things that we can see. Primarily, we saw an alert for suspicious Java chat process, followed by a couple of malware prevention alerts. The exploit I invoked from log4shell does just that. It does try to download malicious files and run them. This is exploits I've seen from honeypot data, so this is what people have been trying to exploit in the wild. We can see here, thanks to the Elastic endpoint and the security views, we get a very nice process tree view of what happened. And again, the malware prevention alert, as well as some threat intel indicator matches. These are all standard out-of-the-box rules, by the way, so it's not like I created anything custom for the specific exploit. We do have some threat intelligence enrichments here, and we can see that this is now given a high risk profile as well. But from a security analyst perspective, I don't know that this is log4shell, right? I have no idea that it was exploited. But thankfully, I have all the applications on this host using our application performance monitoring, APM. Since they're Java applications, it's very easy for us to instrument. So I'm going to pivot to that view. It's within the exact same console. We're going from security to observability instead. And I've got my application running in Google Cloud. You can see it's very clearly indicated over there. And I can see a couple of transactions which happened. If we click on the transaction, we'll be able to get pretty much everything that the application did at that point in time. I'm just going to go to the first sample here, and we can see that it was invoked via curl because I ran this manually. But first thing we see is the main instance of the transaction being invoked. It was a Java application, yes, we know that. But we can see in the request header, this is what that exploit looked like, right? To the eyes of the analyst, it ended up being the coded base 64 command, but they hadn't seen this yet. There weren't any logs or alerts stating that, or I should say with this content. We got this from the application view, which is great to see. But what is even more interesting is what happened right after. So thanks to this application view, we can see that right after the main transaction was invoked, a GET request to this random IP on this random port was made. And it was actually invoked via the JNDI manager from log4j, which is exactly what log4shell does. And you can see it tried to download this class, which is, again, very indicative of log4shell. So if I'm a security analyst, I had my security alerts trigger pivoted to this application view, and then I have pretty much all the information I need to put 2 and 2 together based on what, even if I just did one second of research online about JNDI manager, I can probably going to tell that it's log4shell. Now, we've basically seen what happened today, right? But what I want to do is use that searchable snapshot feature I was talking about to dive a bit deeper. So what searchable snapshots allows you to do is store data on very cheap storage, like archive storage, like a Google Cloud bucket, but still be able to search it as if it was data from today. So I have a timeline here where I'm going to do just that. Here's a correlation from today, which I ran, which essentially I'm looking for processes like curl and wget. And within a 2-minute time period, we want to see if those processes made any network connections on our Google Cloud firewall data. And we can see that happening right here. We've correlated based off of the destination IP. And thanks to the rich information I get out of my logs coming from PubSub, this is really easy for me to understand what happened because all the detail is provided in there. But if I wanted to go back and say, let's now search instead of today, let's go over the last 1 year. Elasticsearch in the background knows that it should use the searchable snapshot. So we do that automatically. As an analyst, you don't have to decide where to look from. So my data from July 22nd, 2021 is telling me, listen, you've had requests to that IP address that was hosting the malware. And we've gone and looked on that archive. This is set up in our index lifecycle management policy. So you can see here, I have a frozen phase, which goes into that searchable snapshot repository. And just to show you as well, if you look at the data storage size for those logs stored in the snapshot, on the physical storage of my cluster, it's saying 0 bytes, which means it's all in the archive. So there's nothing, I'm not using expensive storage from my compute instances. And that's pretty much it from a demo perspective. We'll wrap up with a couple of more slides.
Thanks for that, James. Hopefully you all saw how powerful it can be to combine application data with security data into a single platform such as the Elastic Stack. Thank you all for joining and enjoy the rest of the conference.